Welcome to solverfy.
So in this question we have discussed about sloping turning point. So let's start the explanation now. So we have some explanation. So we know that the value of the function, the value of the function, the value of the function is constant in the level curve is constant in the level curve in the level curve. So the value of the function is constant in the level curve. So the directional derivative, so the directional, so the directional derivative at any point, derivative at any point, at any point in any direction along the level, in any direction, in any direction along the level curve, along the level curve is zero. In other words, the dot product, in other words, in other words, the dot product, the dot product of gradient function of the gradient function of the gradient function and the level curve is 0, and the level curve is 0. So which means they are perpendicular, they are perpendicular, therefore any vector along therefore therefore any vector along any vector along the level curve is the level curve the level curve is orthogonal. The level curve is orthogonal, perpendicular, orthogonal, perpendicular, orthogonal, perpendicular to the gradient vector the gradient of a function the gradient the gradient of the function the gradient of the function is always is always perpendicular is always perpendicular to the level curves of the function to the level curve of the function. So this is the so let me discuss. So the value of the function is constant in the level curve, so the directional derivative at the point in any direction along the level curve is zero. And in other words, the dot product of the gradient function and the level is zero, which means they are perpendicular. They are perpendicular. So perpendicular. Therefore, any vector along the level curve is orthogonal perpendicular to the gradient vector. The gradient of the function is always perpendicular to the level curve of the function. So this is the final explanation of the question.